hello everyone. I'm Sudeep Charles and I head product marketing for Chef Desktop. With me today are Chaitra, who leads product management for this product, as well as Rishi from our engineering team, right? So over the next hour, we'll cover an overview of Chef's easy to implement declarative configuration management capabilities and what can it do for your Linux laptop fleets in particular. We'll do a little bit of a demo that you can actually see how this works, and also what you can gain as a result of that, right? So with that said, let's get started. Right, so endpoints in general, right, are difficult to manage, and according to the cost of insecure endpoints, which was a study conducted by the Ponemon Institute, 63% of companies indicated that they really can't monitor off-network endpoint devices, right? And all of this results in them really spending a lot of money, and that money is in the vicinity of about 6 million annually to mitigate these vulnerabilities, right? And of course, the same survey again revealed that about 80% of organizations, had disorganized endpoint device security strategy, and a lot of that is because IT estates are vast, and they usually run different operating systems that are inherently very difficult to manage in a unified manner, right? So that'll give you a sense of the cost to manage just diverse, large IT estates. Now, what are the challenges in managing, laptop control and visibility? There are two parts to this. One is you can see the survey on the left, which talks about the fact that a lot of developers are married to Linux systems, right? And for good reason, right? It's flexible. It gives them a bunch of capabilities that other operating systems don't. And a lot of these respondents want to continue using Linux, right? So it's not like you can wean them off Linux and give them a different operating system and hope things are back, will get back to normal. So that's on the one side. But what is the consequence of all of this? It's basically multiple things, right? So device mobility, in that users of these devices typically connect to corporate resources, and they don't need to necessarily be connected to a VPN. Right. So in a world that's distributed today, not everybody is co-located at the same office behind a firewall. Hybrid models are being pursued. The cost of then managing these endpoints that are not necessarily behind firewalls is, especially when there is high device mobility, is fairly complex. Then, of course, there's shadow IT, right? And I won't preach to the choir. You definitely are aware of this. Like IT administrators typically don't have visibility into all the programs and all the devices that are running on systems, right? So just trying to verify what's essential and what's not, what can be certified by IT and what can't, is in itself a task, right? And that itself is something that Chef Desktop resolves quite a bit, and we'll see how. Then, of course, there's unregistered devices, right? Now, a lot of these are fortunately or unfortunately running Linux. And a lot of these devices typically are not registered with IT departments. IT really doesn't even know that they are connecting to, their networks. And that causes a hazard, right? Because you have a wider attack surface, you've got 0-day vulnerabilities. All of this can become quite a bit of a challenge very quickly. Then, of course, there is security solutions for isolated endpoints, right? So what do? You then start to isolate these endpoints. You start having, separate solutions for all of these. And very soon you're left with a lot of point solutions that may not talk to each other, that may not give you the visibility that you need, right? And all of this adds to complexity in managing it, complexity for your teams that are managing it, a lack of a unified visibility to your entire fleet. All of that starts to creep in just because of the fact that you're isolating these endpoints and trying to treat them differently, right? So all that is great, but what can you do to kind of gain visibility to your Linux laptops, right? And you'll see a lot of what I'm going to say is fairly generic, but they hold true, especially when you look at Linux, right? So one is you're going to be able to predict at least the situational awareness of what your attack surface is, right? And the minute you're able to get a sense of what the attack surface looks like, you also have a good sense of operating systems, programs, users that are part of this surface, right? and with that, you're able to enable system hardening. You get a full understanding of what it takes to make sure that these surfaces are hardened, devices are hardened, and therefore better protected. You're able to discover better, the kinds of flaws that might affect you, because when you know what kind of devices are in your estate, you also know what the vulnerabilities are that can actually attack those kind of devices, or can compromise those devices, right? So you're able to then discover that better. And as a result of all of this, you stop reacting to adverse incidents, you start responding better, right? Because you're able to very clearly put in place mitigation processes. You're able to very clearly, visualize how these processes are actually working, and if there are any, holes in the entire process, right? So very clearly, all of this is more probably is more nuanced to Linux systems, simply because of the fact that a lot of new zero-day vulnerabilities tend to make Linux systems more compromised. They might not compromise it, but you will find that a lot more of these vulnerabilities are discovered with Linux systems. Well, how does Chef Desktop actually work, and how does it help you? Right. One, it scans your laptops, your Linux laptops in real time, detects, what is the available software and hardware. It provides you a fairly good sense of what the inventory looks like, what devices have checked in, what have not checked in, what are the durations since they have not checked in. And all of this is constantly updated. It also monitors endpoint health, right? It helps you, look at whether your end devices have the right kind of policies updated. If they're not, they can be quarantined, and you can do this at scale. You can also disable or block illegal devices and programs from, entering those entering your network, just by, enforcing these policies at the end device. So you're actually extending the perimeter out, not just from your data centers, but towards your endpoints, which adds better depth to protecting your IT estate. And of course, there is continuous monitoring of your endpoints, right? Without actually relying on physical access to these devices, and you can do that at scale. And both of these, right, doing it at scale and without physical access to the device, both are extremely important in today's world. Well, why Chef Desktop, right? A bunch of reasons, but typically, and I'll let you peruse through the slide, but it helps you reduce time to manage a lot of these devices at scale. It increases streamlining of processes and therefore decreases cost and effort. You're able to get a unified view of everything that's in of your IT estate. You're able to figure out if there are compromised systems or systems that aren't hardened. And of course, you're going to be very efficient in exercising control over this entire estate in a unified manner at scale, and quite honestly, without even actually physically being in touch with any of those devices, right? So that's a very quick gist of what to expect from the rest of the webinar. But as we go forward, and Chaitra will cover a lot of this in more detail, but you'll see a few pop-up poll questions that come in, and one such will pop up right now. Please take the time to respond to this, and we'll discuss the answers to these poll questions towards the end of the webinar. So with that, I'll hand it to Chaitra to take us through the next bits of the webinar and through the deep dive as well. Chaitra.
Thanks, Sudeep. All right. So talking about Linux endpoints in the fleet, right? So there are various reasons why some organizations have Linux laptops or VDIs in their fleet. Developers and programmers prefer Linux operating system as their primary machine for multiple reasons. So Linux distros are highly customizable, which is suitable for developers, and it improves the overall experience, user experience for them. Also, Linux operating system works well for developers working in cutting edge technology like robotics, AI, etc. Right? And some Linux distributions come with pre-installed developer tools, making it better for programming. They're really lightweight, and even if it bloats up, you could easily get rid of it if you really wanted to. And then there is ease of installing different kinds of software on the machines with package manager using short commands. And Linux being open source, you can write your own commands and their functions the way you want them to work. And generally, they perform better than other operating systems and are touted to be more secure and reliable. So although there are advantages with using Linux laptops and desktops, there are challenges when it comes to managing Linux endpoints. There are very few mature tools out there that effectively manage Linux endpoints. There are a few UEMs or MDMs which support Linux platforms, but the support is limited. And even if they are, supporting they're limited to one or two flavors of Linux. Hence, most organizations manage their Linux laptops very manually, or the developers manage the devices themselves, which is not ideal from a security perspective. Manual processes could also hinder the efficiency of teams and lead to mistakes and accidental changes. Due to this, there is no single pane of glass, or there is no centralized visibility where IT teams can view the state of Linux endpoints along with other end user machines that they have on the fleet. So configuration management tools are often used to manage and configure Linux servers. So in Linux, everything is a file, right? So this concept goes very well with task automation, and you can effortlessly access devices from the command line. And hence, configuration management tools work well with Linux servers as well as endpoints. So configuration management tool, they also let you extend DevOps principles to manage endpoints, which could be really helpful in the sense your endpoint configurations are represented as code, which provides great flexibility and control. You can have a CI/CD pipeline and follow SDLC processes. And you can also specify compliance standards that you want your fleet to adhere to. DevSecOps principles, they consider security and compliance reviews early in the cycle, which help in ensuring security, and they also do not cause any delays in rolling out releases. So let's talk about how Chef configuration management tool can be beneficial if it is used for managing Linux endpoints. So one is you can use a single tool chain and process for managing both your Linux servers as well as endpoints. So if your organization is using Chef to manage Linux servers, then some of the content that you can easily repurpose them to manage Linux endpoints as well. So Chef makes it easier to define your configurations as code. As Chef comes with a large number of code abstractions, you don't have to bother about complexities like what command to run, etc. Right? So you just have to call the abstractions with a few parameters, and the underlying complexities will be taken care of. So configurations in Chef are represented as code, and they are defined in artifacts called cookbooks. And Chef has a wide and active community who post their cookbooks in a place called Chef Supermarket. So if there's a cookbook that you need for some, say, specific use case, you don't have to write them from scratch, right? You can browse the supermarket for content posted by the community, and you can use them as is, or you can customize them to suit your needs. And you can also post your cookbooks that you write on the supermarket for others to consume. With Chef, you can also achieve compliance, right? So Chef even provides premium content for compliance controls which adhere to CIS benchmarks. That way you can quickly get started with compliance postering of your fleet. And finally, you can use a single tool for managing Windows, Linux, and Mac devices with Chef, and visualize the entire fleet on a centralized dashboard. And Chef also provides supports to multiple Linux flavors. So just briefly listing out the different flavors supported by Chef, like Ubuntu, CentOS, Linux, Debian, Solaris, etc. So let's take a look at how a Chef desktop setup looks like. So typically, IT admins will bootstrap the laptops or desktops. So bootstrapping in the sense, the Chef client is installed on each of the end user device, and IT admin then pushes configurations to the Chef server. So the Chef client which are installed on these devices, they pull those configurations from the Chef server and apply them onto the endpoints. And the state of the fleet can be visualized on a centralized dashboard. So this is a simplified version. So the configurations push to the server are specified in the form of Chef artifacts called cookbooks. And these cookbooks have individual recipe files where the configurations are defined in the form of code abstractions called resources. So zooming in a little further, right? So with Chef, you can follow a proper software development lifecycle process. It can help you to easily maintain and audit all the configuration changes that happen on the fleet. So a cookbook can be pushed to the source code management repository, which can trigger a CI/CD pipeline. And any changes to the cookbook is peer reviewed and well vetted and tested before being pushed to the production. So once the cookbooks are uploaded to the Chef desktop server, the Chef client deployed on each device pull these cookbooks and apply them onto the machines. So every time the cookbook is updated, it is tested, and the latest changes are pulled by the Chef client onto the devices. So even if there are like configuration drifts done manually by some user, the drifts are automatically corrected, as Chef clients can be, scheduled to run periodically, and any change in configuration from the desired state is automatically fixed. So the state of your entire fleet, the compliance test results, and all the changes done in your fleet can be viewed on a single visibility dashboard. So Chef provides a single pane of glass for managing devices with different operating systems like Windows, Mac OS, and Linux. With Chef, you can essentially have a common language shared among your teams. The language is just the codification of configuring your endpoints, which is readable for any stakeholder who needs to understand what's being configured on the fleet. So the benefit of managing endpoint configurations as code is that you have the ability to collaborate in a common language in human readable code. Using code abstractions as an alternative to scripting is more efficient and prevents you from having to write lengthy, complex scripts. As you can see with the example on the screen, if there's a certain setting that you want to configure, or there's an application that you need to install, all you need to do is pass a few parameters to the Chef resource, and Chef will figure out how to do that setting by running the required commands. Chef's code first approach helps set up an SDLC process, ensuring that changes are well vetted and tested before pushing to the production. It makes the overall cost of change less expensive and increases the productivity of IT teams. And with Chef, you can scale beyond a single system in a consistent, repeatable, and reliant way. So one can also use Chef for ensuring continuous compliance on the fleet. You can codify security and compliance standards, which is readable for any stakeholder who needs to understand what's being codified in order to certify compliance. Managing security and compliance as code is the only way you'll enable your organization to have continuous compliance. So the benefit of managing compliance and security as code is that you can shift your security testing left from the far end of the process, which typically happens in the traditional way of doing things. And then it gives you the ability to continuously monitor the status of your security and compliance with dashboards. So one can essentially drive security and compliance through code into a continuous compliance state where security is no longer a barrier, and in fact, it helps you speeden up your processes and releases. So before we move on to the demo, you'll see a poll question pop up. So do take time to respond to this poll. Yeah. So I will hand over to Rishi, who's going to walk you through a demo.
Thank you, Chaitra. Okay, so before we start with the demo, I just want to inform everyone that this is a pre-recorded demo. So just to respect everyone's time, and yeah, so let's start with it. And we are going to cover the ways we can configure and ensure compliance for our Linux endpoints. So as you might already know that Chef has a lot of premium content around remediation, and we also have the desktop premium content with some of the recipes and resources that you can use out of the box. And then we have Chef client resources that you can use. And then we have CIS profiles. And on top of that, you can also write your own inspect profiles and custom cookbooks. So there's a lot of ways you can leverage all the Chef resources. Okay. So, and to do all of that, we just need a recipe file and a policy file. That's pretty much the bare bones, right? And you can also write them in YAML configuration files. So it doesn't necessarily need to be a Ruby file. And you can see this one is in Ruby, but it can just be YAML. And you can ignore all the other files in here, the engineering team and all that. It's from previous demos. The only ones we are concerned with is the policy file here, base Linux, and the linux.rb that has the Linux recipe. So as you can see, we have apt update, which is equivalent to apt get update in Linux. It will just fetch the package information, and then there's Teams installation, time zone configuration, and we have set up infra client to run every hour. And once that is set up, we just add it to the policy file saying, take the Linux recipe from my custom cookbook. So you can say custom Linux. So that's Linux recipe from the custom cookbook. That's on the cookbooks directory. So you take that and you add it to the run list, and whichever node has the base Linux policy, we just apply all these cookbooks that we have added. So you can see the remediation content that we provide is also available. So we'll take a look at what it does later on in the demo. So back in the terminal, we would just go to the policy files directory, which has all the policies, the engineering and the front-end team and all of that. You might also have different policies based on your requirements. So we'll just run chef update base linux.rb. And what this will do is it will generate a policy log file and make sure that all of these are checked in. So just let it run. Yeah. So you can see there's a lot of other things here which we didn't add. So Chrome, the Git, Firefox, VS Code, and all that. So this is inherited from our base policy, the base.rb. And it's essentially, you could say, a base policy that we want for all the devices in our organization. So all the other policies can inherit them. And so once that is done, we'll just run chef push, and we'll push it to a policy group that we are going to assign to our node. So this once this runs, our nodes can just pull in the configuration and do that. Now we'll move to our node, which is running Ubuntu. So I've already set up the client.rb file with all the necessary configurations. So the server URL, the data character configuration, and the policy name that it has to apply. And I have the validation.pem. So this would be used for bootstrapping it. Ideally, would remove it after it's bootstrapped because we have a client pem after that. So now I'm just going to run chef client. And this is going to apply all the configurations. Okay, so looks like it's almost complete. We just skipped to it. It would take a long time. So I just skipped to the end. And now we are going to check if Teams is installed or not. So you can see Teams is there, and we'll check if Chrome is there as well. I apologize for the lag. It's the remote desktop connection. Yeah. So yeah, Google Chrome is there. Now we'll take a look at how the client runs look on the dashboard. So this is our node list, and we'll just find the Ubuntu node that we ran there. So this is the one that we looked at. And you can see there's a bunch of stuff chef client configured. So you can see Google Chrome is there, and then there's the team installation. So you can see install teams, and then there's the time zone configurations. It looks like it has configured and reported it properly. And yeah, there's the Google Chrome one. So now let's take a look at the compliance. So we'll take a look at the custom profile that we wrote. So we have installed Teams and we have configured time zone, but we need to also make sure that it stays that way, that we ensure that, yeah, it's installed and configured properly. So you can see we wrote a control time zone configuration, and then it's just a bash script that would return the time zone. So we just match it. So it's as simple as that, and we don't need to do a lot of things. So same for Teams, we just list out and we check if Teams is installed. And we can also configure based on flavors. So you can see there's for Fedora and there's for one for Debian, right? So now we just run inspect compliance login to authorize ourselves and then upload the profile to the Automate server. So once the profile is uploaded, the next time Chef client runs on the node, it would pull in the configuration because we specified in our attribute files that find this profile and run for the system. So now once that Chef client run is complete, it is going to report back to our Automate server. And let's take a look at how that looks. So you can see there's a node failing and there's a node that passed. So we'll take a look at the node that we configured, which is the Ubuntu node 2. And we can see the Teams install and the time zone configuration checks have passed because we configured them. And we can also take a look at the source code for the inspect profile. So the time zone configuration also has completed. And then there's a bunch of tests failing because we didn't write remediation content for that. But then there are checks that passed because we use the remediation content from Chef, the premium content. So yeah, that's pretty much the configuration that we needed to do. So with just a couple of lines, we are good to go. We have configured the Linux environment and we have made sure that it's compliant. So yeah, with this, I'll give it back to Chatra.
Yeah, thanks, Rishi. You'll see another poll question pop up. So I would request you to provide your answers. I'll pause for a few seconds for, so that you can provide your answers before we move on to the last section. All right. So in the demo, we saw recipes and compliance controls to manage a Linux endpoint, right? How to schedule your Chef client runs and get the overall visibility of your nodes on the dashboard. Now, let's talk about where does Chef fit into desktop management. So Chef Desktop was launched in early 2020. It essentially uses the same components and tools and technology that is used for managing and automating server configuration. So Chef has proven it in the DevOps space from many years, and it is only logical that we extend Chef to managing endpoints as well. So even though the Chef desktop product was officially launched early 2020, some of our customers have been using Chef to manage their endpoints as early as 2015, and they've been able to manage tens and thousands of machines with just a small team of 2 to 3 people, right? So they were able to do this because they were representing their endpoint state as code and were automating most of their manual processes, which help them manage a large fleet of devices. With Chef Desktop, you can drive efficiency through automation. By automating mundane manual configuration tasks, you can reduce IT setup tickets and avoid mistakes, enable faster time to productivity for employees, and reduce downtime and achieve quick system update management. Right? You can also gain control over and manage IT resources consistently across the enterprise. So Chef can manage multiple operating systems. Using the same tool chain and process, you can manage Windows, Mac, and Linux endpoints. And a Chef really increases the efficiency of the team. You don't have to write multiple scripts to achieve a configuration. And you can do the same, achieve the same use case with code abstractions in Chef. So we call these code abstractions as resources in Chef. If there's a certain setting that you want to configure, you just need to pass a few parameters, and Chef will figure out how to do that setting by taking care of the complexities. For example, if you take the file resource in Chef, it is used to create or delete a file on the end user device. You don't have to bother about how to create that file in Windows, Mac, and Linux. You just have to provide name to the file to the resource, and Chef will figure out how to create that file in different operating systems. You can use a single cookbook to manage a large fleet with different operating systems with centralized visibility. And finally, you can reduce security and compliance risks of your fleet, right? By monitoring your laptop and desktop fleet for compliance through CIS benchmarks provided by Chef. Any and all changes can be audited through code, and you can achieve rapid IT resource hardening or remediation, whether it is for a single laptop or the entire fleet. With Chef, you can automate desktop management via code that can be made pipeline deliverable. Manage configuration through Chef curated content. So Chef provides premium content cookbook, which has recipes for the most common endpoint management use cases. These recipes are available both with Ruby and YAML templates. You can manage company-wide fleet regardless of whether it is Windows, Mac, or Linux. Detect when a laptop or desktop configuration drifts, and automatically correct any necessary misconfigurations. So the Chef client can be configured to run at periodic intervals of your choice. So if there are any drifts, when the next Chef client run happens, it identifies the drift and automatically fixes them, bringing the device back to the desired state, which was specified in your Chef cookbooks. And Chef provides a high level of flexibility, which you can define, where you can define your own resources and have customized recipes, extensible configuration controls to meet each organization's unique needs, or even have department specific, team specific, or even user specific configurations. And all this is possible because your endpoint configurations are represented as code with Chef. Chef Desktop also has a visibility layer, like we saw in the demo. It enables continuous visibility into the configuration status of the fleet. The visibility dashboard shows the status of all the devices, irrespective of whether it is Windows, Mac, or Linux. You can see how many laptops checked in, how many did not. You can also view the check-in history and find out the status of your device over a period of time. You can further drill down and view device-specific attributes like client version, OS version, status of the client runs, the cookbooks that were deployed, etc. Right? And apart from this, you also have a compliance dashboard for checking the compliance posture of your fleet. So Chef empowers IT resource managers through compliance as well. With Chef, you can consistently enforce security and compliance policies with Chef curated content, or you can write your own compliance profiles to meet customer specific compliance needs. You can continuously detect security or compliance issues and allow for automatic remediation with Chef. There is compliance content available for different operating systems and different versions of each of the operating systems as listed here. Finally, what does Chef Desktop bring to the plate, right? You will be able to do more with less resources. We've seen our customers managing, thousands of endpoints with just a few people, 2 to 3 people on the team. And you'll end up having less tickets and mistakes with, most of the process automated. There are just very few things that can go wrong. And you can achieve continuous compliance. You will not only be able to bring the fleet to the desired state, you can continue to keep them in that state by proactively monitoring the fleet and correcting non-compliant devices. And all the changes are tracked, right? Since all the changes that you do are version control, you'll be able to track everything from who made a change, what change was made, when the change was made, to what are the changes that occurred over a period of time, which makes it easy to debug or track issues when something goes wrong. Finally, you'll have a single process and tool for managing configurations and ensuring compliance of your entire fleet with Chef. So with this, we've come towards the end of the webinar. If there are any questions, please feel free to post them and we can answer them for you. We'll also be discussing the results of the poll towards the end.
Great. So while we wait for those poll questions and the results of those poll questions to come in, let's take a look at the questions that we do have that were asked. There are quite a few. So let's start. The first one, right? How can you reuse content used for managing Linux servers to manage Linux laptops? It's a good one.
Yeah.
Chaitra?
Yeah. So Chef client comes inbuilt with many resources for managing Linux, right? So if you have cookbooks calling these resources to manage Linux servers, the same cookbook can be reused or repurposed for managing Linux endpoints as well. Probably you just require to do a few minor modifications. For example, the time zone resource, which we saw in the demo. If you're using that to configure time zones on your Linux servers, it can be reused for managing not just Linux endpoints, but even for Mac and Windows. Chef will figure out how to perform the configurations on different operating systems. But then, you can also write your own resources and customize them to suit your needs.
Got it. Got it. The next question asks, does Chef Desktop have a separate license for supporting Linux endpoints?
No. So by default, if you have a Chef Desktop license, you can manage Windows, Mac, and Linux points with it. So Chef Desktop comes with in two SKUs. One is the Chef Desktop Manage, and the other is the Chef Desktop Compliance. So with Chef Desktop Compliance queue, you're also entitled to premium compliance content, which would audit as well as remediation content for Windows, Mac, and Linux. These compliance profiles adhere to CIS benchmark standards. Like I said before, they can be customized or tweaked to meet your needs or organization standards.
Sure. The next one is also a very interesting one. So the question asks, how do you test configuration changes with Chef? This comes in a little bit of our policy of code, a policy as code as well, right? But I'll let you answer,
Yeah.
Chaitra.
Yeah. So Chef actually comes with a tool called Test Kitchen, where which you can use to automatically test cookbooks across any combination of platforms and test suites. So Test Kitchen will create a virtual machine or a cloud instance, install a Chef client on these VMs, and validate your cookbook against that. So once you're done testing, you can also destroy the Test Kitchen instances. And optionally, you can also have a staging environment where you deploy your cookbooks and test them out. And only once you're satisfied, you can deploy them onto the production. So yeah.
Sure. And do type in your questions into the chat interface, and we'll definitely address them. In the meanwhile, I see the results are up on the first question, right? Does your organization have end user Linux laptops or desktops? A majority saying that they don't have end user Linux laptops in their organizations, but 40%, which is not an insignificant number, are managing a combination of Mac and Windows systems. So does seem like in this audience we don't have too many, but broadly, or at least in some cases, you do have a good combination of Windows and Mac instances. But it'll be good to see what percentage of those are Windows and what percentages are Linux and Mac systems. Great. Let's move on to the responses of the second poll, please. Right. How many end user Linux laptops are there in the organization? So this is fairly nuanced, right? So either on the lower end, on the extreme lower end, or on the extreme higher end. Chaitra, what are your thoughts?
Yeah, so number of Linux endpoints may be very few in some organizations, but it is important that they are managed well and adhere to compliance standards. Security has changed considerably over the years, so it is important that they are secured and not left to be managed by the users on their own. And even if it's a small fleet of Linux devices, a tool like Chef, where you can manage your Windows, Mac, and Linux with a single tool, helps you minimize the number of tools that you have in your system to manage your fleet. And it is interesting that some of you have a large Linux endpoint fleet. Chef works really well with scale, right? So you can easily manage a large fleet with custom configurations for different departments and teams in your organization. So yeah.
Great. Um, do we have the next poll questions result? Well, I guess we're having some technical problems with that, but
Okay.
right. So I think let's just skip that for now. Great. So if there are any other questions, please feel free to drop them in, and we'll address them post the webinar and directly to you. But otherwise, we'll call it a day. Thank you so much, everyone, for your time today. This webinar will be available to you on demand on the Chef site, or you'll probably receive an email that tells you about this link, and you can share that link with others that might also be interested in viewing this webinar, right? So with that said, thank you all for your time. Thank you, Chaitra, Rishi, and thanks once again. Have a good rest of the day.